In today's lesson, we will be solving equations with variables on both sides. So again, we're going to be using those inverse operations and distributive property throughout this in order to solve equations from both sides. So after this, you should be able to say that you can do this or after our activity in class. In the first example, I drew out what's called algebra tiles. So these longer rectangular ones are our x tiles, and then these are our constant tiles. In this case, we have positive constant terms. So I have 7 x tiles and or plus 4 constant tiles equals 9 x tiles. And this will help give us a visual in order to solve this equation. So I'm going to draw my line here to help separate the sides. If I want to get solve for x, I need to have x only on one side. I don't want to have it on both sides. So I need to start taking away or moving them over to the same side in order to solve for x. So in this case, since I have 7 x's on one side and I have 9 on the other, if I start taking away those 7 and I take away on both sides to keep my scale balanced, so what I'm doing is subtracting 7x. That will get me down to just having a 4 equals 2x. Now I have my like terms combined on each side. I'm taking away all those extras, so I only have x on one side, and then I can break it up and divide it into 2 groups and know that x equals 2. Now when I go to check this here, you want to plug it into both locations of those x's. So I have 7 times x. I'm going to plug in the set at the 2 at the x spot, plus 4 equals 9, and then times 2 again. When I'm going through this, I'm going to use my order of operations on this left-hand side, get an amount, and then do my order of operations on the right-hand side, get an amount, and hopefully those two amounts or answers are the same. If they are the same, that means I did it correct. If they are not the same, I probably want to go back and check my work. So I'm going to go 7 times 2 is 14, plus 4, and that gives us 18. I'm done with that side. Now I'm going to try to see if it equals the other side. 9 times 2 is 18. So yes, that does check. So when you are doing that checking process, remember you are following that order of operations. We'll do one more check together, and then I'll let you, from there on out, you can do a mental check or you can do a check on your calculator. It might be a little bit more difficult to do a mental check on these problems than it was on the 1-step and 2-step problems. So you do want to get comfortable with writing out your checks so that you understand it. All right, so from here on out, it's up to you if you want to draw those algebra tiles. If that makes sense to you, go ahead and draw them so that you can get that visual in what you are doing with the problem. So here I'm just going to do some color coding. I'm going to identify my like terms so that I can see that I need to combine my like terms or move, in this case, my like terms across that line. So when I'm moving my like terms together, I need to do the inverse operation. So I'm going to move my x's first. I'm going to start with the 3x, but I could have started with the 8x. If I have a positive 3x, remember, I'm looking for the sign in front of it, not the sign behind it. So that's a positive 3x. I'm going to do the opposite of a positive, or adding 3x. I'm going to take it away. I'm left with 2x equals 5x plus 13. Now it looks more like our 2-step problem, so hopefully it's a little bit more comfortable for us. I could still highlight those different colors there if I wanted to. And I could say, okay, well, I have that 13. It needs to be combined over with the 2, but I'm going to cross over that line, so I have to do that inverse operation in order to move it over to the other side. And so I get negative 2 minus 13 gives us negative 15. My last step is to figure out how much is 1x instead of 5x's, so I'm going to divide and get negative 3 equals x. Let's do one last check with this, and then I will let you check on your own from here on out. So again, I'm going to follow my order of operations on one side. So 3 times negative 3 is negative 9, and then I'm subtracting 2 more, so I get a negative 11. Then I'm going to go to the other side, see if it's equal, 8 times negative 3 is negative 24, plus 13, so I'm spending $24. I have $13. I'm still going to owe $11, so that is equal. If you think you're ready to tackle the next one on your own, go ahead. If you want to keep watching the video, you can keep watching the video. Remember, this is tailored to you. I'm going to highlight those like terms again. So I see those fractions. I want to move one over to the other side so they're together. I'm going to move over the positive 1/3. So the opposite of adding 1/3 is subtracting 1/3. 1/3 x, I should say. And I have I'm subtracting my fractions, so I want to find a common denominator. Easiest way to do that is just to multiply it by the other denominator, so in this case 4 and 3, so I get a common denominator of 12. And then I'm going to subtract and get 5 over 12. So I have 5 12ths x plus 2 equals 7. Now I can look for my like terms, and this time I have the positive 2 here, and across the line I have that positive 7. So I want to move over that positive 2 by subtracting 2. And hopefully this looks familiar, that we have this multiply by a fraction. Remember, we want to think divide by that fraction, but really we're going to multiply by the reciprocal. And our 5's cross off and our 12's cross off into 1's over on the left-hand side. That gives us 1x. And then on the right-hand side, our 5's cross off again, and we're going to multiply and get 12. All right, our next problem, we have, in number 4, we have some parentheses. So hopefully the first thing that you're thinking in your brain is that you need to do the distributive property. Again, if you feel like you're ready, feel free to pause the video, try it out on your own, or just continue on and watch. So the first thing, like I said, what I want to do is I want to distribute here. So I get 6x. Remember that negative 3, or that minus goes with that 3, so 6 times negative 3 is negative 18. Notice my minus sign is my negative sign, so I don't write minus negative 18, it's just minus 18. Be really careful with that. And then I'm going to distribute the 2. So I get 8x, and again I'm thinking that minus 5 equals negative 10. Let me draw my line, and let me throw in some color. So I can see all my like terms. So I'm going to start off with my like terms that I see over on this left-hand side and combine them. You don't have to. There's many ways that you could go about this problem. But I see negative 18 plus 10, and I want to combine those to get negative 8. And then I could notice my like terms, the 6x and the 8x. So I have a positive 6x. I'm going to subtract 6x over to the other side. I tend to move the smaller x value if it is possible, so then I have less negatives to deal with. I'm not always going to be able to do that, but that's the strategy that I tend to lean towards, so then I have a little bit less of negative values going on. But you don't have to. Like I said, there's multiple ways to do this. So now I see my two-step problem. I have a minus 10, so I'm going to add 10 to both sides, and I get 2 equals 2x. And my last step is to divide by 2, x equals 1. Now, not all of our problems are going to look the same. So some of our problems are going to be special cases. So first of all, in our one solution problems, this is like examples 1 through 4 that we just did, where we get an answer at the end, such as x equals 4, or x equals 3, or x equals 2. We still have the x value. We know what x is. We have something to plug in to check our answer. Now, there are going to be times where our x disappears, and we're going to get either a false statement or a true statement. And what happens here is we're really figuring out where two lines cross at, and we'll get more into that in the later of the year. And two lines don't always cross. So if they don't cross, that would be a no solution. If they cross at one spot, that would be one solution. If they are the same exact line, they are infinitely many solutions. So that means infinitely many solutions means I could pick any number for my x value, and I'm gonna plug it into the problem to check it, and it's gonna work. Whereas no solution means I'm gonna plug in any number for x, and it's never ever gonna work. One solution means this is the only number that I can plug in there to check my answer, and this is the only one that works. If I were to plug in a different number, it would not work. So let me give you just a very short or small problem here. If I had 3x minus, I'll do plus 3 equals 3x plus 2. I have x's on both sides, so I would subtract my 3x, and my x's disappear, and that's what makes it a special case, is that the x's go away, and I get this answer that makes no sense. I get this answer of 3 equals 2. Obviously, $3 does not equal $2, so that is a false statement. I could get 0 equals 7. I could get negative 10 equals 50. Anything that is not true, if the x's go away, this is only true if the x's go away, that they cross off on both sides, then it is no solution. So I would write down no solution and be done with it. Now a short example of infinitely many solutions would be, say again, if I had 3x plus 2 equals 3x plus 2. If I subtract 3x on both sides, my x's go away, and I get a true statement of 2 equals 2, or maybe 0 equals 0, something that is true. So my answer would be infinitely many solutions. We're going to do a problem of each. So in the first one here, I'm going to follow my steps. I'm going to do my distributive property, and I get 12x plus 24, and then I do my distributive property over here, and I get 12x plus 24 again, so that should kind of be a little sign there that something weird is going on, that I get the same thing on both sides. But maybe I'm just working through the problem. I know I need to move my x over, and it crosses off on both sides. I get an answer of 24 equals 24. That is true. I could stop there. Maybe I'm really not paying attention. I didn't notice that, and I get 0 equals 0, and I subtract the 24s. That is still true. So that means I have infinitely many solutions, and the way that I write infinitely many solutions is with that infinity sign, and then solutions. So you must write infinitely many solutions. That is your answer. Again, I could pick any number and plug it into the check, and it's going to work. So I could plug in 5 or 10 or 100, and every number that I pick, it will always check and always work. So my last one, number 2, now when I do my distributive property and solve, it's going to look a little different at the end. So 20x plus 12 minus 6x equals 14x plus 21. So here I notice like terms right here, 20x and a negative 6x. So maybe I get that together first, combine those like terms. Remember, combine doesn't necessarily mean add. In this case, we're subtracting because it says to subtract. And then I notice those 14 x's on both sides, so I want to get them over together. I take it away because it's a positive 14. And I get 12 equals 21. Well, that doesn't make any sense. So that means that there are no solutions. Again, this time if I picked any number for x, it will never ever work. I'm always going to get a different number on both sides, so I would never be able to check my solution.
Do not forget to do your summary, so 2 to 3 sentences on how to solve equations with variables on both sides. Be sure to write one of those sentences at least talking about special cases. And then your question for today is to solve for n minus 4 equals 3n plus 6. attempt the problem. If there's any struggles or frustrations or confusions, make sure you just make note of it, and when we go back to it in class, we'll clear up any confusions.